Okay, lesson 54, parabolas. This is the first of 4 lessons I'm going to do for you this week, and make sure you watch them all because these took me a long time to do, and it helps you to do them the right way. We're going to talk about parabolas today, and what they are. Parabolas are also called conic sections. Is one of several conic sections. A conic section is formed when a plane cuts through a cone. I'm going to show you a picture right now from the book. See if I can move my little window over. Hang on a second. Okay. Here's a cone, and there's a plane cutting through the cone. It forms conic sections. If the plane goes perfectly parallel to the x-axis, it forms a circle. If we tilt it like this one, we will get a parabola. Here's what that one looks like, a parabola. Every parabola has an axis of symmetry, so here's some pictures of some parabolas. Like that. We won't, if the parabola is on its side like this, or diagonal like this, or like that, it's not a function. So we're going to be dealing with the parabolas whose axis of symmetry, which is the line that goes right down through the middle, is vertical. So that's the kind of parabolas that we're going to be doing. And we already did circles a little bit, which is a conic section, and there's still a couple more conic sections that we're going to do. Now the basic form for conic section, the graphable form of a conic section, is this formula right here. Y equals A x minus h quantity squared plus k. If we can put our quadratic equation into this form, we can graph it easily because we can just look at it and see where the axis of symmetry is. The axis of symmetry is h. So we know that the line going right down the center is going to be x equals h. It's a vertical line going right through the point h. It's the opposite of this. It's not the negative number, it's just the h. So if this is x minus 2, the axis of symmetry would be 2. We can look at this and also see the vertex. The x-coordinate would be right on the axis of symmetry, so the x-coordinate is h, and the y-coordinate is k. A, which we're not going to deal with too much in this book, the number in front tells you how wide it is. If it's a 3 or 4, if it's a whole number, it's going to be more narrower than if it's a fraction. The fraction ones would be wider, the whole number ones will be more narrow. The bigger the number, the more narrow it's going to be. The thing we are going to concern ourselves with, though, is whether the A is positive or negative. If this value in front of this quantity is positive, it's going to go up. If the value is negative, it's going to go down. So here's an example. If we have y equals x plus 2 quantity squared minus 3, we can graph it by plotting the vertex, and then we know it's going to go up because this is positive. It's going to open upward. And we can also find the axis of symmetry. X equals negative 2. So we can put points on either side. We can easily just pick one point and then find the matching point on the other side, and we'll graph it. We're not even going to pick the matching point on these. We're just going to sketch them. So what this lesson is graphing these. Here's the quadratic equation in standard form. We're going to complete the square in order to get it into the graphable form, and then we're going to graph it. So let's get going here. We have to get into this form, so we're going to complete the square. This number in front of the x squared, if you're going to complete the square, remember it always has to be a 1. So the first thing you would have to do is factor out the number that's in front of here, if there is one. You can't divide everything by that number because then you'll be dividing the y by the number, and that just won't work for graphing. If this was equal to 0 when we were completing the square, then we could divide everything by the number that's common. But this one doesn't even have that problem. So to complete the square, you would write y equals x squared minus 4x, and we're going to complete the square, so we need to get rid of that 2 since it's not a perfect square, and replace it with a number that is a perfect square. So we're going to put the minus 2 out here. If we add something onto here, typically what we do is we subtract it off, we add it also onto the other side. But since we want it in a graphable form, we can't just go adding a number to the other side. So what we're going to do, if we add something onto here, we're going to subtract it off the end. Remember how to complete the square. You divide the middle term by 2, and then you square it. So 4 divided by 2 is 2, squared is 4. So we're going to add 4 to make a perfect square trinomial, and we're going to subtract 4 in order to keep this equation balanced. So we're going to get y equals, we made a perfect square trinomial so that we can write it like this, x minus 4, x minus 2. Hold on a second, I just bumped my pen. X minus 2 quantity squared minus 6. So now we have it in graphable form, and we can easily sketch a graph of what this is going to look like. Hold on 1 second, make sure I didn't make a mistake here. Yes I did. This should be A. I'll start over. This should have been a plus 2. Right there. That should have been a plus 2, and so this should have been A minus. This should have been a plus 2, and this should have been A minus 2. Sorry about that. That just has to move. I don't know why I changed that to a negative 2. So now we can graph it. Our axis of symmetry is x equals 2. Remember, it's always the opposite of this. And our vertex is hk, which would be 2, negative 2. So we're going to just graph those two things and sketch our parabola. Then we are going to pick a point. So our line of symmetry is going to go right down here at x equals 2. Can't do super straight lines, but that was pretty good. That's our axis of symmetry. Usually you make it dotted. And then our vertex is negative 2, is 2, negative 2. So here's our vertex. And then you just want to put in one point to see how wide your parabola is going to be. And we can look at this even from here. If we put in a 0 for x, we're going to get the point 2 for y. You can always find your y-intercept by looking at the equation and looking at this number out here. That's always your y-intercept. Because if x is 0, that's going to be what y is. So we went 2 this way, so we're going to go 2 this way. And once we have our points on there, we just draw our parabola. Not really good, but you get the idea. Alright, let's try another one. The only difference for this one is it has a negative sign out in the beginning, which does make a difference when you're completing the square. 1 second, so I move this thing over. Okay, it won't move over soon. Alright, so we're going to complete the square with this guy. So we're going to get y equals. Remember I said you can't have any kind of coefficient out in front, so we have to factor it out before we even begin. I'm just going to actually factor it out of these first two guys. So we're going to get negative x squared plus 6x plus something, and I'm just going to kick that negative 8 out even before we factor it out. We're going to complete the square. We're going to divide the 6 by 2. And we're going to square it, so we can get 9. And now this is a little bit tricky. This 9 is not, we wouldn't just subtract 9 off the end because it's positive 9. This is really a negative 9 because of this negative sign outside. So this would really be a negative 9, so that means we have to add 9 onto here. The last one we subtracted what this was, but because we have this negative sign out, we have to. This would really be a negative 9, so we have to add 9. If this would have been a 2 out here, a negative 2, it would have been a negative 18, so we would have had to add 18. Which I think we might get into more complicated ones later, but I'm not sure. So now we could put it in the graphable form. Y x plus 3 quantity squared plus 1. Now we can graph it. We have our axis of symmetry is -3, and our vertex point is -3, 1. And this one's going to open downward because of this negative sign. So let's put these things on our graph. We have our vertex at -3, -1, -3, 1, 1, 2, 3, 1. And this is going to be our, this is how you normally do it. It's too bad. This is our axis of symmetry. We know it's going to open downward. We know our y-intercept is right here. So we can put our y-intercept on at -8, 1, 2, 3, 4, 5, 6, 7, 8. And our other side is going to be, this is over 1, 2, 3. So we go over 1, 2, 3 and put our other point on. It's just easier. You don't even have to really substitute in to get your point. You just look at this number at the end and you know where the intercept is going to be. So we just draw that in. And that's all there is to graphing parabolas.